Hello guys, welcome to the class. In this class, I will solve a question from Coulomb's law, which came in Neet 2016. The question is, two identical charge pairs suspended from a common point by two massless strings of length L are initially at a distance d apart because of their mutual repulsion, and the d is very much less than the length of the string L. The charges began to leak from both the spheres at a constant rate. As a result, the spheres approach each other with a velocity v. Then v varies as a function of the distance x between the spheres as. So the question is that, and you have to find the answer. Out of the four options, one will be the correct option. So let us first understand the question. So see, initially the two spheres have some charge. These two spheres have some charge. Let's say this is q, and q is not constant. Q is changing with time because charges are leaking from the spheres. After some time, the charge will not be q, it will be less than q because it is decreasing at a constant rate. Means q is changing with time. dq dt is constant. So minus c I am writing. I'm writing minus c because it is decreasing at a constant rate. C is a constant. So rate of change of the charge is constant and it is decreasing. That's why this negative sign. Okay. And if the charge is decreasing, then the force of repulsion will also decrease because the magnitude of charge is decreasing. So if the repulsion between these two charges are decreasing, then they will start approaching each other. And if they are approaching each other, let's say they are approaching each other with a velocity v. Let's say they are approaching with a velocity v, and at any instant, let's say at any instant they will be at a distance x. Let's say after some time they are at a distance x. Obviously x is less than d because they are approaching each other now. Okay, in that case it will have a velocity with which they are approaching each other, and v is related to x, and you have to find what is the relation between v and x. If it is x to the power a, then what is that a you have to find. Okay, this is the question. Okay, let's say now let's approach the problem. Okay, so I can easily resolve the force acting on the two spheres. Let's say this angle now theta. Okay, if this angle is theta, if I draw, okay, so this angle will also be theta. Let's say tension in the string is T. If it is T, then the component of tension here will be T cos theta, and is this direction, and in this direction it will be T sin theta. This T cos theta will balance its weight mg. Okay, and this T sin theta will balance the repulsion between the two spheres. Let's say this is the force of repulsion. So now I can write, so what I can write now, that T cos theta balancing the weight mg, and T sin theta is being balanced by the force of repulsion, which is nothing but k q by the distance square at the time. The distance at the time is x, so x square. Now if I divide T sin theta by T cos theta, means if I call it 1, if I call it 2, and if I divide 2 by 1, then I get k q square by x square and divided by mg. Okay, so I am having tan theta equal to k q square, which is a function of time, x square mg. Now see, in the question it is given that d is very much less than L. If d is very much less than L, then x is also very much less than L, because x itself is less than d. So what does it mean? It does mean that theta is very small. If theta is very small, I can write tan theta is close to theta, and I will use this fact that tan theta is very close to theta. So what should I write? I will write theta equal to k q square by x square mg. Now see, what will be theta? Theta will be simply x by 2 by L. See, from here, what will be theta? Theta will be this portion divided by the length. So it will be, so the full length is x, the full length is x, so the half will be x by 2. So I am writing x by 2 by L equal to k q square function of time x square mg, or I can write x by 2L equal to k q square by x square mg. From here you see q square t is equal to something, some constant times x cube, because see, L is constant, k is also constant, mg is also constant. So these things mg, k, 2L, they will give a constant term, right? Let's say this constant is k. Let's say here I already written k, so I'm writing k dash, where k dash is nothing but a constant thing, and q square is equal to a constant thing times x cube. Or I can write q square t, or I'm writing qt, let's say, is equal to some constant thing, I'm writing, let's say, some constant thing times x to the power 3 by 2, right? Okay, so then I am writing qt is proportional to x to the power 3 by 2. Now if I differentiate with respect to time dq dt, then it will be 3 by 2 x to the power 3 by 2 minus 1, that is half. But what is, and also dx dt. But see, dq dt is nothing but a constant thing, because the rate of change of charge with respect to time is constant. Some c is proportional to now 3 by 2 x to the power half. And what is dx dt? This is nothing but velocity, rate of change of position. This is nothing but velocity with which they are approaching each other. So v is now proportional to 1 by, so minus c by 3 by 2 x to the power half, or v is proportional to, see, these things are again constant. Okay, so it will be nothing but x to the power minus half, because these things are constant anyway. So b is related to x as x to the power minus half. So this is the correct option. So the correct option is option A. Option A is the correct option. Okay, thank you.